In this video, we're going to do the first installment of pyramid surface area and volume. So we're mainly going to cover pyramid surface area. So to start off, we're going to talk about the parts of a pyramid. There's the vertex. Okay, the vertex is where all of the faces come to a point at the top. The lateral edges are the edges that go around the lateral faces, so not the base. Okay, the lateral faces are the faces, the triangles that go around the base. The base is the polygon that the pyramid sits on, and we'll talk about the different kinds of bases that a pyramid can have. And then a base edge is exactly that. It's the edges that make up the base. Okay, some other parts as well are the altitude. The altitude is the height perpendicular to the base, and it connects to the base and the vertex of the pyramid. Okay, so it goes from the top of the vertex straight down. All right, so it connects to the base that way. The slant height, okay, or the slant length, L, is the length of the altitude of a lateral face. So the slant height is what goes along the face of the pyramid, and the altitude is what comes down straight into the middle, straight down from the top of the vertex, so where all three of them fit. So let's talk about parts of a pyramid. So for each pyramid, we want to identify the variable that represents each of the following: the height, the slant height, and the side length of a base. Okay, so the height of the pyramid is actually the altitude. It's the one that goes straight down from the vertex. So that would actually be Z. Okay, the slant height is the height of the face. So the slant height is always going to be on the face. So that's going to be V. And then a side length of a base, okay, that's going to be a base edge. So one of the edges that's attached to the base. So here's our base right here. So our side length of a base is going to be X. Okay, for an oblique pyramid, the altitude is the height perpendicular to the base and connects the base to the vertex of the pyramid. Okay, so here, see, it still is connected to the vertex and it goes straight down. Okay, the slant height is still the length or the altitude of the face. Okay, so here, see how it's still a part of the face? Right? So it's going to go at an angle, but the altitude is always going to be a straight line that goes straight down from the vertex. Okay, so now we're going to talk about the surface area of a pyramid. Okay, the surface area of a pyramid is a little different formula than surface area that we've been talking about earlier. Okay, earlier we've been talking about the surface area of prisms. Okay, so a pyramid is going to have the formula 1/2 L. Okay, L is the slant height or the slant length, and then P is still going to stand for the perimeter of the base, and big B is still going to stand for area of the base. So we still have some things that are common to what we've already been doing, but the formula is a little bit different. Okay, so here we want to find the surface area. Okay, so if our formula is 1/2 LP plus B, we want to put in, first we want to figure out what our numbers are and plug those in. Okay, so remember that L is the slant height. It's the height of one of the faces. Okay, so if we have L here, okay, the slant height is going to be this number right here, 10.77 m, well, meters. So we're going to put 10.77 right there. Okay, P stands for the perimeter of the base. Okay, if we look here, we have a square pyramid. Okay, so if this is 8 meters, then we know that this is 8, and we know that this is 8, and this is 8. So we know that the perimeter, when we add them all up, 8 plus 8 plus 8 plus 8 is 32. Okay, the area of the base, right? Area of a square, side times side, 8 times 8 is 64. So now we just want to take all these numbers and multiply them together and then add them after that. So 10.77 times 32, and then we want to divide that by 2. So we're going to get 172.32, and then we want to add that to 64, and that's going to be 236.32 meters squared. So that's the surface area of a square pyramid, okay? And whenever we have whenever we're talking about pyramids, again, just like prisms, we classify them according to the base, all right? So this is a square, so it would be a square pyramid. You can also have a rectangular pyramid if we had a rectangle. Here we have a triangular pyramid, all right? So we're still going to use our same formula, only now the formula that we use to find area of the base is going to be a little different because our base is a triangle. Okay, now our slant height, remember slant height is the height that is connected to the face. Okay, it's the altitude of the face. So for this one, it would be 14.4. Okay, the perimeter of the base is we're going to add up all the sides. All right, now this is an equilateral triangle. And I know we cut off some of the words here, but that it'll tell you that it's an equilateral triangle. And if it's an equilateral triangle, then we know that this side is also 12 kilometers and this side is also 12 kilometers. So we know the perimeter, 12 plus 12 plus 12 is 36. Okay, now to find the area of the base, all right, it's a triangle, okay? Now, it's not a right triangle, okay? So we can't take 12 times 12, because remember the area of a triangle is 1/2 base times height, okay? And the height of a triangle has to be perpendicular, okay, from the vertex to the base. So if we look here, the height of our triangle here is actually 10.4, okay? So in order to find the area, we would say 1/2 times 12 times 10.4. which is 62.4. So the area of our base is 62.4. So now we're just going to take these, multiply them out, add them together, and be done. 14.4 times 36, and then divide it by 2, is going to be 259.2. And then we're going to add 62.4 to that, and it's going to give us 321.6 kilometers squared. Okay, so on this pyramid, right, we're going to count the sides here. 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagonal pyramid because we have an octagon right here. So we're still going to use our same formula. Okay, the slant height, remember, is the height of one of the lateral faces. Okay, so if we look here, we're not given the slant height, okay? But if we look right here, we are given the altitude, right? It goes straight down, and we're given the apothem. And look, it makes a right angle. So we actually, from these two numbers right here, we can find the slant height because this will make another right triangle. So here we can use Pythagorean theorem to find the slant height. So the slant height is going to be our c squared. So remember, Pythagorean theorem is a squared plus b squared equals c squared. So we have 14 squared plus 4.8 squared equals c squared. So 14 squared is 196, 4.8 squared is 23.04. So we add those together and get 219.04 equals c squared. So we want to take the square root of that, and that's going to give us 14.8. So we know that the slant height is 14.8. So now we can plug that in for L, 14.8. Okay, now we want to find the perimeter. So remember, perimeter is just adding up all of the sides here. So we know that EF here is 4 centimeters. Okay, we have 8 sides, so 8 times 4 would be 32. Or, if we added up 8 times, we would get 32. Okay, now we want to find the area of a base. So we have an octagon here, right? It's a regular polygon. So our formula is going to be 1/2 times the apothem times the perimeter. Okay, so our apothem then is going to be this right here, the 4.8. And then our perimeter, we already found that one earlier, right? We found it to be 32. So we're going to take 32 times 4.8. And then we're going to divide that by 2, and we get 76.8. So now we just have to finish this out. We're going to take 32 times 14.8, divide that by 2, and we get 236.8. And then we're going to add that to 76.8. And our surface area is going to be 313.6 centimeters squared. And that is the end of finding surface area of a pyramid.